Hi guys. In this video, we're going to go over problems very similar to the ones you're going to see on quiz 2. Which is covers chapters 6, 7, 8, 9, and 10. So we're going to start with chapter 6, economic growth, and look at a problem that requires you to use the growth formula, which is the GDP or whatever the quantity is that you're measuring for growth. But in this case, it's GDP per capita. So we take the GDP per capita at the starting date, multiply by 1 plus the growth rate of the GDP, and then we raise that to the power of the number of years that you're looking at the growth. So if we take a GDP per capita of $5,000, we put that right here, right? The GDP at the start. We multiply that by 1 plus the rate of growth, or the annual rate, which the problem gives us at 2%. So we write that in a decimal form, 0.02, and we raise that expression to the power of 20, since it's asking us for 20 years. So if we're going to use a calculator, which I'm sure that you are, and you certainly should, we just let's take what's in parentheses first. So we're gonna, where's my calculator? So we're gonna go 1.02 raised to the power of 20. So we're going to use our x raised to the y function right here and plug in 20 equals, and then we're going to multiply that answer by the GDP at the start, which is 5,000. So times 5,000, and we get our answer of $7,429. And I just rounded this off the 0.7369. I rounded that up to 74 cents. Okay, so let's just do one more here just to make sure that we have this. So the next part of the problem is asking us to compute the rate of growth, or compute the GDP at the end of 40 years with a 2% rate of growth. So we're gonna do this calculation right here with our calculator. So we just take clear this, 1.02 raised to the power of 40 equals times 5,000. And that's going to give us our answer right here that I rounded up to 20 cents. Okay, so that's how you do the growth formula, or the growth rate problems. You're going to have plenty of time to do this quiz, so I would highly encourage you to work each of these calculations twice, just to make sure that you don't make a silly mistake with your calculator numbers. Okay, punching in the wrong one or something. So just I would do each one of these twice. Okay, next we move on to chapter 7, which is unemployment. And we're looking at a problem where we're given the population of a country, we're given the number of adults that are employed, we're given the number of adults that are unemployed right here, and we're told that the rest of the adult population, the rest of this 8 million is out of the labor force. So the first thing we want to do is compute or calculate the unemployment rate. So we're going to put in our numerator the number of adults that are unemployed right here, and divide that by the denominator, which is the total number of adults that are in the labor force, which is the number of employed, 5 million, plus the number of unemployed. So we get 5,500,000 in our denominator, and we multiply that answer by 100 in order to get our answer expressed as a percentage. So let's just pull up our calculator here really quickly, and we're going to clear that, and we're going to save. Now, what I'm going to do here is, since I can see that there's the number in the numerator and the number in the denominator both have 5 zeros, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm just going to not use the zeros and simply divide 5 by 55. Now I'm going to get the correct answer, which is 0.0909. So times 100 is going to be 9.09. So I rounded that up to 9.1% for our rate of unemployment, or unemployment rate. Now, the next question here is the problem asks you what share of the population, so what percentage of the population is in the labor force. So we simply take the total number of adults right here that are in the labor force, and we divide that. So that's going in the numerator. And then in the denominator, we're going to put the total population, which we're told up here is 8 million. And then to get the answer expressed as a percentage, we multiply by 100. So let's see. So we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So I'm going to take away 5 zeros from both of these, so I don't have to risk making a mistake by punching in the wrong number of zeros. It just makes it less likely that you'll make a mistake with your calculator. So I'm going to divide 55 by 80, because I took 5 zeros. See, 1, 2, 3, 4, 5. That leaves me with 80. And 1, 2, 3, 4, 5 leaves me with 55. So I'm going to divide 55 by 80 and get 0.6875. In order to express this decimal answer as a percentage, I'm going to multiply by 100 and get 68.75% as my answer. Okay, there you go. So we're moving on in this first video. I'm going to do this actually in 2 parts. So this is part 1. So the last thing I believe I'm going to do, let me just check real quick. This is going to be inflation, and then that's going to be okay. So I'm going to do the problem for chapter 8, and then I'm going to do chapters 9 and 10 in part 2. Okay. So chapter 8, inflation. So we're looking at calculating inflation using index numbers. So we take one year and make that year equal to 100, right? And we call that our index number. And then every other year is a ratio of the base year, which we're using, which we are assigning the index number of 100. So we're in this problem, we're well past the base year of 100, so we're up to 110 to 115 and 115 to 120. So if the index representing the price level changes 1 year from 110 to 115, and then in the next year from 115 to 120, does this mean we have a 5% that our rate of inflation is 5% each year? Easy. Right? Wrong? No, because we're looking at not just the change in the number, in the index a number, which here obviously is a 5 each time. That's not how we compute the rate of inflation. We do it by looking at the percentage change. So when you think about 110 changing by 5 or increasing by 5, 5 is a larger percentage of 110 than it is of 115. So when we look at percentage change, we're going to get a slightly different percentage for our rate of inflation. So the way we do this, the calculation, is we simply compute percentage change, which is where we ended up, right, minus where we started, divided by where we started, and then we multiply that answer by 100 in order to get our decimal answer expressed as a percentage. So let's just do one of these with our calculator just to make sure we know what we're doing here, right? So 115 minus 110, I'm just going to use my head for that and say that's 5 divided by 110 equals 0.4545 forever. And we're going to multiply that by 100, and we're going to get our percentage of 4.54. So I just rounded that to 4.5%. Now, just to prove that it's a different, let's just do the second one. So when we do the second one, we're actually dividing 5 here by 115, right? Not 110. So of course we're going to get a slightly smaller rate of inflation. So let's just do it. So 5 divided by 115 is 0.0434, and way out there. So then we're going to just multiply by 100 to get it expressed as a percentage, and we get 4.34. So I just rounded it down to 4.3%. So there you go. So that's that. Now you're going to have your first 3 problems on your quiz are going to be very, very similar to the problem I showed you here for economic growth, the problem that we worked here for unemployment, and the problem that we worked for inflation. Now, once again, you're going to have plenty of time for this quiz. You're going to have 2 hours, so I would highly encourage you to do all your calculations twice, just to make sure that you're not making a silly mistake. Okay, that is the end of part 1. In part 2, we'll talk about the problem for chapter 9. Chapter 9, international trade and capital flows, and chapter 10, the aggregate demand, aggregate supply model. Okay.